Good morning. Today we're going to work some problems with Vertex form, specifically practice sheet 14.2. Each of the problems ask us to do three things. One, write each quadratic equation in Vertex form. And just a reminder, Vertex form looks like y equals a, which is our coefficient of our square term, parentheses x minus h, that whole thing squared, plus k. And whereas number two, it asks us to find the coordinate of the vertex. We can do that real easy when we have it in vertex form. The vertex is the h comma k. Now notice that our h in our vertex form here is a negative. So we're always going to take the opposite of what's in that parenthesis when we write the vertex as an ordered pair right there. And then lastly, we're going to find the solutions to each quadratic equation. The method we're going to use today is using completing the square, which we did in the previous lesson in 14.1. All right, so to write each in vertex form, we're pretty close to start with here. Anytime we have standard form, which is what we have here, we can be equal to 0, we can be equal to y, we can be equal to f of x if it's a function. And if you notice, our vertex form wants us to be equal to y. So the first thing I'm going to do is I'm going to change how my equation is written, and I'm going to set it equal to y. So I'm going to go y equals our b squared, plus 10b plus 24. So all I did was replace 0 with y, and that's cool. We can do that. If you don't like the b square, then make it an x. If b's bother you, my b's kind of look like 6's, but I think we'll be all right. Okay, so now here's where I'm going to do the completing the square. So I'm going to leave the first two terms alone. I'm going to use them to complete my square. So I'm going to draw my line, I'll add and draw my line. I'm going to put a little parentheses here so we separate it so we know that's what we're going to complete the square with. I can't change the value of my equation, so I still have to carry down that plus 24. So remember from our previous lesson, to complete the square, we take half of the middle term, and then we square that number, and that's what we put in the blank where we've added. So half of 10 is 5, and 5 squared is 25. Now, we're on one side of an equation here, and that number really didn't stick out a whole lot, did it? I was hoping it was going to stick out better than that. All right, so let me go to a different color here. Let's get something that sticks out a little bit different than the black. Okay, so half of that 10 was 5, squared is 25. There we go. So if you notice, we're on the right-hand side of the equal. So we added 25, so we somewhat changed the value. So to keep from changing that value, we got to do the opposite. So we're going to subtract 25 from that same side. So I added 25, and I subtracted 25. So really, I didn't change the value any at all. Okay, now complete the square. So we're going to factor that. This perfect square trinomial here is going to factor into b plus 5 quantity squared. On the outside over here, 24 minus 25 is minus 1. And now there's my vertex form. If you go back up here to where I had it originally, a parentheses x minus k, x minus h, that whole thing squared, plus k. So there it is. So my vertex, let's change colors again. My vertex is the point -5. Remember, we said we always had to take the opposite of this in here. And -1. All right. So I've written vertex form. That's here. I have found the coordinates of the vertex. That's here. And now I got to find the solution. So now I'm going to solve where I wrote my vertex form. So now I'm going to kind of go back to what I did before. Now I'm going to replace that y with a 0. Remember, I did that originally. I replaced the 0 with a y. going to add 1 to both sides. And I'm going to take the square root of both sides. So I get plus or minus 1 equals b plus 5. And then I'm going to solve those two equations. Let's see, I'll come over here and do that. So positive 1 equals b plus 5. Subtract 5. And b equals negative 4. And negative 1 equals b plus 5. Subtract 5. And b equals negative 6. So negative 4, negative 6 is my correct answer. And that's the solution to my equation. All right, let's try another one. Let me erase all this stuff. Okay, notice this time it's a little different. Number 1, we were equal to 0. Number 3, we're not equal to 0. We're equal to negative 3. And that's going to be the first thing I do, is add 3 to both sides so that I'm equal to 0 like I was a minute ago. So now I have k squared minus 14k. My 42 and my 3 I added to both sides give me 45. And now I'm equal to 0. And just like I did before, I'm going to replace that with a y. I'm going to leave my blank there so that when I complete the square, I'm in good shape. All right, change color ink. So when I complete my square, I take half of the negative 14, negative 7, square that, 49. Undo my adding 49 so that I don't change the value of the equation. So I subtract 49. Take the factor of this perfect square trinomial that I created here inside the parenthesis. So remember, perfect square trinomial factors into the square root of the first, so k squared, the square root of that's k. Square root of the last, square root of 49 is 7, and I always use the middle sign, so k minus 7. And then I put my square out here. 45 subtract 49 is negative 4. So there's my vertex form. My vertex ordered pair, go back to blue. My vertex ordered pair is going to be 7, negative 4. And then I'm going to solve. So remember when I solved, I went back and I changed back from my y to my 0. Add 4 to both sides. Take the square root of both sides. And I get plus or minus 2 is equal to k minus 7. And just split that up. So 2 equals k minus 7. Add 7 to both sides. And so k is equal to 9. And negative 2 is also equal to k minus 7. Add 7 to both sides. And k equals 5. So the correct answer is 9, 5. Hope that helps.